Reading pseudo code. As we saw in the first section of this module, the solution to a problem can often be thought of as a sequence of steps which should be taken in order. The same is true when a program is being written. Generally, you start at the beginning and follow the steps in order until you come to the end, by which time the problem should have been solved. His type of combination of operations is known as a sequence. However, the real power of computer programs becomes apparent when we change these rules. There are a number of ways of breaking out of the simple sequence. We will look at two of them here. 1. Selection. Selection is the process of making a choice. The simplest example is the command if, then, else. This is used to divide the sequence into two possible routes. There is a condition, something like an answer being more than 10, and then two possible outcomes. One is followed if the condition is met, for instance, use a discount price because of the number bought, and the other is followed if the condition is not met, use the standard price. Note that, eventually, all these different routes must either come back together or must have some suitable endpoint. 2. Repetition. There are a number of ways of repeating the same instructions more than once. We will have a look at three methods here. Each one of these methods has two things in common. The first is some sort of pointer that sends control of an algorithm to some point other than the next instruction in the sequence, and the second is some method of controlling whether the pointer is followed or whether the normal sequence of instructions is followed. A repeating construct is often called a loop. The first of these loops is one where the control of the loop is at the end of the loop. It is called a repeat until loop. Note that the instructions in the loop have to be carried out at least once before there is the chance of meeting the condition. The second loop structure is a end while loop. This structure has the condition at the start so that it is possible to miss out the instructions in the loop entirely. The third type of loop is called a for next loop. This loop is repeated a predetermined number of times. A counter keeps check of the number of times the loop has been done, and when it has done enough the loop is exited. Note that with the for/next loop the number of times around the loop is determined before entry into the loop. It is useful to be able to divide a problem into modules so that each part of the problem is easier to solve. When the algorithm is turned into a computer program, it makes sense to program each of these smaller modules separately and then connect them together to make the whole program. These small segments of program are called procedures and functions. To start with, we will call them all procedures. They are very similar anyway, and later we'll see what the difference is. Imagine a computer program. It is made up of a number of instructions taken in order. In this section we have seen some constructs that could change the simple order. If the program has been split into sections by modularizing the algorithm, each of the modules is called a procedure when it is in the form of a program of instructions. The diagram shows a main program which, just under halfway through, runs a procedure to carry out a particular task, which itself runs another procedure. Note two things about these procedures. 1. If they work something out, presumably they must pass the answers back to the main program, otherwise they have been wasting their time. 2. When the procedure has been finished, the next instruction is back where it came from in the first place. This means that the computer must remember whereabouts it was when it went to the procedure so that it can go back there. These 2 points need answering, but not now. We will return to them later in the course. A procedure could be used for putting a menu on the screen, and then another could be used for reading the choice made and acting upon it. At some point a procedure could be used to work out the square root of a number. This is slightly different because the result at the end of the procedure is a value which, presumably, will be used in the main program. A procedure which gives a value at the end is known as a function. Not quite true, but it will do for now. When a question is asked about using these techniques in pseudocode, it will give you a short section of pseudocode which you will be expected to dry run and then possibly be expected to change some of the lines so that it will produce a different result. You will not be expected to write a lot of pseudocode in an exam. However, you may be asked to describe an algorithm.